are studying the first chapter, Relations and Functions. Today's topic is Composition of Functions. We are doing exercise 1.5. The first two sums of this exercise I've done in the previous video. Please go through that. Today we are going to do sum 3. If fx is equal to 2x minus 1, gx is equal to x plus 1 upon 2, show that FOG is equal to GOF is equal to x. Okay, let's find out FOG. FOG is equal to f of gx. Now write down gx. It's given x plus 1 upon 2. So this is equal to f of x plus 1 upon 2. F of x is 2x minus 1. So here we are going to replace this x with x plus 1 upon 2. So this becomes 2 into x plus 1 upon 2 minus 1. So here it is 2 into x plus 1 upon 2 minus 1. 2 will cancel and you will get x plus 1 minus 1 is equal to x. Now let's find out GOF. GOF is equal to G of fx. Write down fx 2x minus 1. Okay, now we have to find g at 2x minus 1. G at x is x plus 1 upon 2. So wherever x is there, substitute with 2x minus 1. So this becomes 2x minus 1 plus 1 upon 2. So write it down. Minus 1 plus 1 will cancel. 2x upon 2 is equal to x. So FOG is equal to GOF is equal to x. Proved. Question 4. If fx is equal to x square minus 1, gx is equal to x minus 2, find a if GOFA is equal to 1. So here let us now find GOFA. It is G of FA. Okay. So G of FA we have to find. So here we can see fx is equal to x square minus 1. So f at a will be, you have to substitute x as a. So you will get a square minus 1. Okay. Now we are going to find out g at a square minus 1. G at x is x minus 2. So here in place of x we are going to write down a square minus 1. So this becomes, this is equal to a square minus 1 minus 2. Okay. So and this value of GOFA is now a square minus 1 minus 2, which is equal to 1 they have given already. So write down this equal to 1. Now simplify this. A square minus 3 is equal to 1. So a square is equal to, bring it on the right side, 1 plus 3, that is equal to 4. So a is equal to 2 or minus 2. So what we have done here, we have first find out this value of GOFA, G of FA, and then we have substituted and we have got this expression which is equal to 1 they have given. So we are going to write it equal to 1. Then simplify, you will get the value of A. Question 5. Let ABC be a subset of n, which is the set of natural numbers, and a function f from a to b be defined by fx is equal to 2x plus 1, and g from b to c be defined by gx is equal to x square. Find the range of FOG and GOF. So let's first find out FOG. FOG is equal to f of gx is equal to f of gx is x square. So f of x square. Now in place of x you should write x square. F at x square will be is equal to 2x square plus 1. So what is the range of this function? Range is the set of all elements such that all elements y we can take such that y is equal to 2x square plus 1, where x belongs to n, because this is the set of natural numbers. It is given that these sets A, B, C are subset of n. Okay. GOF is equal to G of fx is equal to G at fx, write down. Fx is 2x plus 1. So G at 2x plus 1. And we know G at x is x square. So G at 2x plus 1 will be 2x plus 1 the whole square. Open this bracket, a plus b the whole square is equal to a square plus 2ab plus b square. So you'll get this 4x square plus 4x plus 1. So the range here, in this case, GOF will be all the elements y such that y is equal to 4x square plus 4x plus 1, where x belongs to n. Question 6. Let fx is equal to x square minus 1. Find FOF and FOF. So let's find out FOF. F of fx. So write down fx here. Okay. Now again we have to find f at x square minus 1. F at x is x square minus 1. So in place of x, again substitute x square minus 1. So you'll get is equal to x square minus 1 the whole square minus 1. Okay. So in place of x, we are writing this. Now open this bracket and simplify. You will get x raised to 4 minus 2x square. This 1 will get cancelled here. Okay. Now this is FOF. Again we are going to do another composition with f itself. F of FOF. That means f of FOF x. Now we found out this FOF x, that is x raised to 4. Write down x raised to 4 minus 2x square. Now the value of this function at this. Here we have to again substitute x raised to 4 minus 2x square in place of x. So whole square minus 1. Open this bracket, you will get this answer. Question 7. If function f from r to r and g from r to r are defined by fx is equal to x raised to 5 and gx is equal to x raised to 4, then check if f and g are 1 to 1 and fog is 1 to 1. Okay. So let us take fx, x raised to 5. So here f at 0 is 0, f at 1 is 1. These are, we are taking elements of the function, the domain, real values. Okay. So f at minus 1 is 1. So minus 1. So here we can see that distinct elements of the domain has got distinct images. 0, 1, minus 1. You can take any value of x. It will be different, distinct. Therefore, it is 1 to 1 function. Now take gx is equal to x raised to 4. G at 1 will be 1. The value of g at minus 1 is also 1. So here you can see two elements of the domain has got the same image. So it is not a 1 to 1 function. Okay. Now let us find out for FOG what kind of function it is. So f of gx is x raised to 4, f of x raised to 4. So here substitute x raised to 4 in place of x. So you get x raised to 4 raised to 5, that is x raised to 20. So here you can see that if x is 1, the image is 1. If x is minus 1 also, the image is 1. So it is not a 1 to 1 function. So here we have come to the end of the 7th sum. The remaining sums I have put in a separate video. Please go through that also.